Hello my friends, I'm here today at Sholden and we're going to be looking at the wonders of displacement and distance and scalars and vectors. And I'm going to start by running all the way around from Sholden here to the point in Teignmouth, which you can see just ahead of me across the river. It's about 130 metres in displacement, but it's about 1.8 miles of running. Let's go!
It's super chilly. Look at the ice on the beach, on the boats. Anyway, we're going to make our way. It's beautiful here. I mean, well worth its fun. Gorgeous day, freezing cold, but we're keeping going, about halfway.
So here we are on the other side of the river mouth, 130 metres away from where we started, but we've run a distance of 1.8 miles. So let's talk about scalars and vectors. So scalars and vectors are two categories of quantities, really important terms when it comes to understanding physics. And a scalar quantity is one that can just be shown on a scale. It's as simple as that. It only has a magnitude or a size. It doesn't have any kind of direction associated with it. And so terms that we might see with that are things like temperature, which although it has a positive and a negative, it doesn't have a direction. It's not 35 Celsius north. It's just 35 Celsius. That's the quantity of the temperature of that body. Mass is the same. Mass might be 50 kilograms. That isn't anything to do with direction. Same with energy. Energy is in joules, it's just the amount of energy something has. Now distance is where we start getting a little bit more complicated, because distance is a measure of length in meters, but it doesn't have a direction associated with it. So when I ran 1.8 miles, it was not associated in a certain direction. That's just how far I travelled. Speed, similarly, is how quickly you are travelling in meters per second or miles per hour, but not in a particular direction. It's just how fast you are travelling. It might be 70 miles an hour. It doesn't matter which way you're going, that's just the speed that you have. And density is another one. The mass per volume of something, again, doesn't have a direction associated with it. However, a vector does. A vector quantity is one that has magnitude and direction. So it's how much something is happening and the direction that that is going to happen in. So a really good example here is displacement. Displacement is distance with direction. So that's important because if we're talking about my run, for example, it's the direction I've gone was going from that point on Sholden Beach to Teignmouth Point. And actually that's only about 130 metres away. I think it's 130 metres east, let's say, for simplifying it. But the key thing here is we have a direction with it. The distance I ran was 1.8 miles, but the displacement that I travelled, my displacement from start to finish, if you like, was 130 metres, and we'll look at that more in a second. Velocity is the same as speed, but with direction. And this, again, has to have a direction associated with it. So it might be 70 miles per hour north, for example, rather than just having the speed. Acceleration is always using displacement, which is used in velocity, which is used to then calculate acceleration. So this always has a direction associated with it too. For example, g, or acceleration due to gravity, is 9.8 meters per second, or meters per second squared, in the direction of the center of the Earth. Force equally is using a concept of acceleration in calculating it. So a force has to have a direction. We've got an example here of the gravitational pull from the sun on the Earth. Just a made up number with it, but it's got an arrow to show us the direction. Hopefully you're familiar with drawing force diagrams, or if you're not, you will be soon. And with force diagrams, you have an arrow showing the direction of the force, but also the size of the force. What's the wonder of an arrow? It has a length and it has a direction. It has a size and it has a direction. Or it has a magnitude and a direction. So therefore it's got to be a vector. And so forces are really good examples of vectors. And another one which will come on later in this topic is momentum, which is also a vector quantity. Now, as I said, vectors can be represented with arrows, and this is because they have a size and a direction. The length of the arrow is the magnitude, and the direction of the arrow is, well, it's the direction. Simple as that. But when you need to draw these vector arrows, or these directions the vectors are acting in, and their size, you need to choose a scale, and you need to stick to it. So, for example, you could go with 1 centimetre is equal to 1 Newton. So let's say we have here this boat, and it is being forced up with up thrust, and it's in equilibrium, so it's not sinking and it's not flying out of the water. It must have a counter force which is pulling it down, which is weight. And these two have been drawn to scale. Let's say that 1 square is equal to, 100 newtons. And so therefore its upthrust is going to be 3 squares, or 3 centimetres, or 3 of whatever the scale ends up being. So it would be 300 newtons. And the weight would also be 300 newtons. Okay, and for a car here, again, if you draw a force diagram, a free body diagram to show the forces here, we've got a backwards force and a forwards force. The forwards force is 3 squares. Let's say the forwards forces again are still the same scale, so 1 square is 100 newtons. The driving force here would be 300 newtons, and the drag, or the air resistance and the friction, would be 200 newtons. So here we can see we have a difference, and that goes on to talking about resultant forces. But that size and the direction is really important. If something has a size and a direction, it must be a vector. So let's talk about my run a little bit more and put into the examples of displacement and distance. So you can see here the 2 maps of what I've run. One is from Strava, just showing the distance I've run tracked out on the road, and the other is the displacement measured out in Google Maps from one point to another. So you can see in the distance I've journeyed all the way around the estuary, across the bridge, and then through Teignmouth back to the seafront, back to the point. And that's a total distance of 1.82 miles. So that's how far I actually travelled, with no direction associated with it at all. It's just how far did I go, start to finish, how far did I actually travel. Displacement, though, is just the direct comparison from where I started, position A to position B, ignoring how I got there, ignoring all the rest of it. It's just actually how far am I at the end compared to where I started. And that's an actual measurement, a displacement of 134.13 meters. Okay, and we need to have a direction with that too. I mean, north would be up here, east would be over here. So it's what, north, east, east, I suppose you could say. What you could also do is you could actually get a compass and you could actually work out what this bearing is, what this angle is, and actually find out what bearing I've journeyed through. And really we should be including that when we're talking about our displacement. But here, let's say for simplicity's sake, 134 meters east. However, my distance travelled was 1.82 miles. 2 very different quantities. Of course, the one that I was most concerned about was the distance I was going to travel, but it was nice to show a really good point. So that's our overview of scalars and vectors. If you have any questions on any of that, please do drop a comment below and I'll do my best to answer it as best I can. Thanks for watching.
That is one cold boy.